Welcome to the Embedded Systems at NTH channel. In this video, I'll be tutoring over the characteristics of embedded systems. So embedded systems are standalone devices mostly. It is a computer system with a dedicated function within a larger mechanical or electrical system, often with real-time computing constraints. It is embedded as a part of a complete device, often including hardware, software, and mechanical parts. Examples of embedded systems are elevators, traffic light systems, swipe cards, tablets, weather forecasting systems, multiple touch sensing, VLSI design, traffic servers, physical electronic games, LED pattern plays, cell phones, printers, robots, X-ray machines, biomedical and automation, guitar tuners, prosthetic hands and bionics, application in digital signal processing, video games, anti-lock braking systems, automatic dish and cloth washers, etc. Here is a recent example of an embedded system. This is a Raspberry Pi, a credit card sized board. On the Broadcom system on chip, it has an ARM11 microprocessor, a GPU, a 512 MB RAM. Here are the GPIO, that is general purpose input output pins, audio jack, LEDs, 2 USB ports, 1 Ethernet port, 1 HDMI port for new monitors, RCA video jack for old monitors. It boots through its OS through an SD card, and since it's not a standalone device, it can be configured for many purposes. For example, a wireless Tor proxy server that we had a go on. More in the links in the description below. Components of embedded systems. Embedded systems have processor, timers, interrupt controllers, input-output devices, memories, serial and parallel communication ports, registers, muxes, demuxes, data and address buses, UART, ADC, DAC, RTOS, input-output, interfacing, driver circuits, actuators, accelerometers, motors, rotors, etc. Real-time operating system defines the way the system works, which supervises the application software. It sets the rules during the execution of the application program. A small-scale embedded system may not need an RTOS for sure. The operating system may or may not have a graphical user interface depending on the type and the want of application where it is being used. Characteristics of embedded systems. They should be reliable, easily available, should be safe, should be secure, that is, they should have authentic communication. They should be fault tolerant, meaning they should continue to operate despite hardware and software faults and glitches. Many of them are single function, that is, they execute a single program repeatedly with the help of interrupts and subroutines. They should be tightly constrained, they should have low cost, they should dissipate low power, they should be as small and as fast as possible. They should be reactive and in real time. They should continually react to the changes in the environment. Depending on the need, they may have hard deadline, for example in anti-lock braking systems, auto parking sensing systems, flight control systems, and soft deadlines like in the video games. They can have significant time delay or in set-top boxes or in cell phones. They should be able to withstand heat, vibration, shock, power fluctuations, RF interference, lightning, corrosion. For example, a glitch that Ericsson had to face in the crisis. Ericsson faced a crisis at the brink of having to invent entirely new embedded technologies, material-wise, to cater to the hot and arid areas of Saudi Arabia, which was the site for the first mass GSM network. Embedded systems should have multi-rate operations. Its performance should be good. Its size should be as small as possible. Should have non-recurring design and manufacturing costs, and it should be code efficient, unlike the Apollo missions where one went down due to the incapability to reach 256 bits when the systems were 128 bit. Extreme cost sensitivity. For example, $0.05 adds up to about 1 million units used in the embedded system. They can be CMOS transistors, etc. They should have dedicated functions towards a certain application. Knowledge about the behavior of physical system and design can be used to optimize runtime and minimize resources. Embedded systems have dedicated user interface. They can have no interface at all, but with human interface after all, like in microwave using LCDs, LEDs, buttons, relays, etc. Or they can have full-fledged OS application interface and firmware. When do embedded systems use FPGAs, that is application specific integrated circuits, or microprocessors, or both? FPGAs provide more semi-customizable programming options, that is they are more programmable than microprocessors are. They use complex algorithms in languages like VHDL and Verilog. Microprocessors are used in high-end workstations with reduced instruction set code, mostly at the expense of lower cost. Is less in performance but is fast, and microprocessors uses software application, operates off a core BIOS.